Hello and welcome to Chemistry with Dr. Z. In this video, I'll tell you all what you need to know about aldehydes and ketones. So the carbonyl group is the group that is formed of a carbon atom that has a double bond with an oxygen. You can find the carbonyl group in aldehydes, ketones, and carboxylic acids. The name carbonyl compounds refers only to aldehydes and ketones. So in aldehydes, the carbonyl group can be found at the end of the carbon chain, and the carbon is attached to a hydrogen. So these are the aldehydes. The ketones, on the other hand, the carbonyl group can be found in the middle of the chain or somewhere in the middle of the chain, and there will be two alkyl groups attached to it. So this is the main difference between aldehydes and ketones. Representing aldehydes and ketones cannot be distinguished by their molecular formula because they basically have the same molecular formula. So we have this aldehyde here and this ketone, this aldehyde with the aldehydic group and the ketone with the carbonyl group between two alkyl group. And you can see that both of them have a molecular formula of C3H6O. To distinguish between them, you need to represent them using either displayed or structure formula. So for the displayed formula for this aldehyde, as you can see, you represent the aldehydic group with the carbon of the carbonyl group with attached to at least one hydrogen. And with the structure formula, this is going to be CH3, and then for the aldehyde, this is CHO. The other aldehyde here, this is again the displayed formula with the aldehyde group at the end of the chain, and then it's CH3, CH2, CH2, and then CHO. The ketones, on the other hand, as you can see with the displayed formula, the carbonyl group is represented in the center or in the middle of the structure. And then when you write the structure formula, you're gonna write CO and write the other part of the chain on the other two other sides. So this one is CH3 first, and then CO, which is the carbonyl group, and then CH2, and then CH3, and same here for the other ketonic compound or the ketone. How to name aldehydes and ketones? First, to name aldehydes, they are named using the suffix al and follow the conventions as for naming alkanes. For example, if we have two carbon atoms, this is going to be called ethanal. So the same as ethane, but you remove the E at the end of ethane and replace it with al. So this is an aldehyde. And then if it's three carbon atoms, because the carbon atom with the carbonyl group is considered as one of the atoms of the chain. So this is three carbon atoms, one, two, three, and this is called propanal. You can also name an aldehyde with some substituents. For example, this aldehyde here, you have one, two, three, four carbon atom chain. So this is butanal. And then on carbon number three, there is a methyl group here. So this is called 3-methyl butanal. For ketones, ketones are named by using the suffix -on and then follow the same convention as for naming alkanes. For example, this ketone has three carbon atoms, so one, two, three. So this is going to be called propanone. And then this one has one, two, three, four carbon atoms. This is called butanone. Normally, when we name the ketone, you should describe exactly where is the carbonyl group. However, for propanone and butanone, the carbonyl group will always be carbon number 2. So you don't have to say it's propan to on or butan to on because it will always be carbon number 2. However, if you have something like butanone, you could have butan to on like this one. So 1, 2, 3. This is carbon number 2 with the carbonyl group. So this is going to be called butan to on, or you could have pent to on, or you could have penta pentane 3 on. So this is 1, 2, 3. Carbon number 3 is the carbonyl group. So this is, you need now to give number to the carbonyl group in the ketone. The formation of carbonyl compounds for aldehydes, you can form aldehydes by oxidation of primary alcohols. So oxidation of primary alcohols will give you aldehydes. However, you should beware of further oxidation because the aldehydes themselves will be oxidized by the same oxidizing agent to give you carboxylic acid. One of the main reactions of aldehydes is oxidation to the corresponding carboxylic acid or the carboxylic acid with the same number of carbon atoms. Ketones, on the other hand, can easily be oxidized from secondary alcohol to give the ketone straight away. So secondary alcohols oxidation will give you the ketone. However, ketones will not be further oxidized to give carboxylic acid. So it's much easier to get the ketone by oxidation of secondary alcohol, while it's not as easy to get the aldehyde from oxidation of primary alcohol because they will be further oxidized. So the identification, how to identify the presence of the carbonyl compounds. So first of all, we can use the IR because we have the carbonyl group and we know that in IR, the carbonyl group will give us a strong peak around 1500 and 1600 centimeter minus 1 in the infrared spectrum. So this is strong, this strong peak can give us identification or can tell us that there is a carbonyl group. In addition, you can identify between or distinguish between aldehyde and ketones and carboxylic acid because there will be no peak for the OH in case of aldehydes and ketone. However, this method can tell you that there is a carbonyl group, but it will not be able to distinguish between aldehydes and ketone. So to distinguish between aldehydes and ketones, we can use either Tollens reagent, where Tollens reagent is a colorless solution of silver nitrate in aqueous ammonia. And when we heat and when this solution is heated in a test tube with aldehydes, aldehydes will be oxidized to give the carboxylic acid, and the silver will be reduced to give the silver mirror. So this is the positive test where you can see the silver mirror here. Only aldehyde will give positive for this test. However, ketones are not oxidized because we know that ketones will not be oxidized to carboxylic acid and will give a negative Tollens test. The other method or a third method or a second method which can distinguish between aldehydes and ketones is the filling solution using of the filling solution or filling test. So filling test again is a blue solution of copper 2 ions or copper 2 compounds dissolved in aqueous sodium hydroxide. So it's going to be blue color of copper 2 plus. And when they are heated in a test tube with an aldehyde, the aldehyde will be oxidized while the copper 2 plus will be reduced to give a copper 1 plus or copper plus, which has a different color, which is brick red precipitate. So this is the positive test for the filling solution. Only aldehydes will give positive, but ketones will not be oxidized, so it will remain unchanged. So these two tests, the Tollens test and the filling test, can distinguish between aldehydes and ketones. For the reactivity of the carbonyl compounds with a double bonds, they have double bond here, which is the carbonyl group. So compounds with double bonds tend to be more reactive as there is a possibility for addition reaction. So some of the chemical properties of aldehydes and ketones are a result of the polar nature of the carbonyl group. So the carbon has a partial positive charge and the oxygen has a partial negative charge. And we have a double bond and different groups can be added to this double bond. So the main reactivities or the main reactions for aldehydes and ketones are the fact that the positive charge on the carbon atom make it open to attack by nucleophiles. And nucleophiles are these groups which can have a negative charge, so they can attack the carbon which has a positive charge. Also, aldehydes and ketones can be reduced, and they will form primary and secondary alcohol respectively. So the aldehydes will be reduced to give primary alcohols, while the ketones will be reduced to give secondary alcohols. Finally, aldehydes only can also be oxidized to give carboxylic acids. So let's have a look at these type of reactions. So carbonyl compounds are subject to nucleophilic addition. In nucleophilic addition, we have the nucleophile which has a positive charge, and then we have the carbon which has a partial positive charge, and the oxygen here has a partially negative charge. The nucleophile can attack the carbon, while that allows for the double bond between the carbon and oxygen to open. The oxygen will then have a negative charge, and then we have a proton where in the reaction mixture, and this proton comes from the solvent, which could be water, which could be methanol, and then it will attack the positive charge, the proton with the positive charge, and that will give you the addition product. Well, now the oxygen has changed into an OH, and then the carbon, there is a nucleophile added to the carbon. One of the reaction we talked about is the reduction of aldehydes and ketones. Aldehydes and ketones can be reduced by reducing agents, and the most common reducing agent we used are sodium borohydride. This is a reducing agent. Sodium borohydride dissolved in water or methanol, and also there is lithium aluminum hydride. These reagents are a source of hydride. Hydride is a hydrogen with a negative charge. So this hydride again will act as a nucleophile, and the reaction mechanism is that the hydride will attack the carbon, which allows for opening of the double bond between the carbon and oxygen. That will give you an intermediate with a negative charge on the oxygen, and then we have the water in the reaction mixture, which is the solvent we used. So this oxygen with a negative charge can actually take the hydrogen as a proton, or hydrogen with a negative charge from the solvent, and that will give you the alcohol. So this is the reduction, as if you added two hydrogens to the carbonyl group. Now, if you have an aldehyde, so something like C double bond OH, that was the reduction with having the hydrogen, then you're going to have primary alcohol, so CH2OH. And if you have a ketone like C and then the carbonyl and then R, then with the reduction, you're going to have a secondary alcohol, so COH here, hydrogen, and then another R. And then finally, addition of cyanide. So cyanide can be added as a nucleophile to the carbonyl group as well. Addition of cyanide, you can use either sodium cyanide or potassium cyanide. The cyanide group itself has a negative charge. Again, the same reaction mechanism where the cyanide attack the carbon, which is partially positive, allowing for the opening of the double bond between the carbon and the oxygen. Then the intermediate here was a negative charge on the oxygen that will attack the water or the solvent, and will take a proton from the water, and that will give you the product. This product is called cyanohydrine. So cyanohydrine with the cyanide group here, and the oxygen with the added hydrogen. You can use either, as we said, sodium cyanide or potassium cyanide. Potassium cyanide is very common to be used in this reaction. However, you should be careful because potassium cyanide is very toxic. It's irritant and dangerous if inhaled or ingested. Also, potassium cyanide can react with moisture to give hydrogen cyanide. Hydrogen cyanide is a very toxic gas. Therefore, when you do this reaction, you need to wear safety goggles, gloves, lab coat, and to work in fume cupboard.